Okay, so question 8 has kind of a similar flavor to question 5, yeah? So they're both combi.
Delicious.
Combi, yes? Combinatorics, yes?
No.
Yeah.
We call it affectionately as combi. Okay, we're counting things.
Combi sounds very traditional.
Combi sounds like
Something from a movie.
a type of band.
Yeah, so in
Video game.
Olympiad math, there's number theory, combinatorics, algebra, and geometry.
Okay,
Okay?
in what?
Like the Olympiad maths syllabus.
There's combinatorics.
Combinatorics,
Algebra.
number theory, algebra, and geometry. Okay?
Number
Geometry
three
is kind of basically getting removed from high school maths because people don't understand that it's actually still in the syllabus. So then, but as a practical consequence, it just got removed. Okay?
What's number
horrible.
theory?
Number theory is like whole numbers, divisibility, prime numbers, unique factorization, you know, like that kind of stuff. Modular arithmetic. Yeah, so about whole numbers, yeah? Algebra is probably the stuff you do at school the most. Okay?
What do we do at school? Matrices.
It actually doesn't matter what you do at school because most of the time the teacher won't be able to deliver the right amount of rigor for. Because even learning the simplest things, you can make it super hard if you examine it very closely, right?
They're making us do coloring and math.
Yeah.
Like, which
Yeah.
school do you go to?
Number theory.
Fluorescent. What we learn.
Like, do you have different classes?
And
Different, like, periods?
Okay, so this is the question. You have all these strings of letters.
different classes.
So you have this set. This set is like the alphabet, right? But instead of having a normal alphabet that goes to Z, this only stops at I, yeah? And they're all capitals.
No.
Not hard.
They're all capitals, okay? So there's 9 things here, right? And so yeah, okay. So and the question is how many, and if you have a string of, you have a word which is defined to be as a string of these letters. So it could be like A, B, J, and it could be out of order, right? H, yeah?
It's not part of this school.
I meant I, sorry. Okay, good. So they're not just words, which are just strings of these letters, but they're also related to each other by the following moves, right?
But you can do as many of those moves.
Yes. So if you can do as many of these moves to get from one word to the other, then those two words are said to be related. Okay. So you're allowed to, for example, delete these double A. Yeah. So this relates this word to BIDH. Yeah.
So it's like I thought it was just really simple. You just don't put any two letters.
Yeah, that's true.
Yeah.
Yeah.
But
then
then
you find out every single thing.
Yeah.
But then you also have to figure out the combination for not two adjacent ones.
Yeah. So when you switch
and then you get rid of everything that doesn't have adjacent.
Yeah. So
How many have adjacent ones?
okay. So that's one move. You're allowed to take away 2 A's, right? Or you're allowed to add 2. You can undo this move as well. You can add 2 A's, or you can just randomly like insert two E's in here anywhere you want. Yeah.
But like,
Just like 2 E's. Yeah.
Video.
Yeah. Okay. So those are the two of the moves, and the other move is you're allowed to swap 2 letters which are next to each other. So you can swap the order of I and D to get DI. Yeah. Does that make sense? So this question, okay, I feel like the way to go with this question is just to be sure it's the answer and don't include any working, because some of the things I feel like are kind of annoying to state. Well, they're not annoying to state, they're annoying to prove, okay? But so for example, it's quite obvious actually if you think about it that if you're allowed to swap any 2 adjacent letters, right?
yeah.
Then you're actually allowed to permute them however you want.
So then you just
Does that make
get
sense?
rid of every combination.
Yeah.
So it just becomes a combination.
So for example,
the numbers that don't have
so you can just assume that they're ordered, right? Because everything's equivalent to something where the letters are in order. Because you can just keep swapping them to the letters that are in order. Yeah?
Wait, I don't get it.
So basically, like if you have a bunch of letters, right?
Mm-hmm.
It's kind of like you have like seats in a movie theater or something. This guy wants to be at the front. They can just go all the way to the front, right? And so you just keep shuffling until all the ones are in order. Yeah? So you can have all the A's, then all the B's, then all the C's, then all the D's. Yeah? Because if A is at the back, you just shuffle, shuffle, shuffle. You just keep swapping with
So
the
you
next
can't have
one until you get all to the first.
So basically, you just don't get any
Right.
double.
So you just don't get any double
Yes,
letters.
a year
anymore.
5 yawn, that is. No, we talk about the conditioning.
It's a combi.
It lasts for 2 hours. Okay, so basically, if you can move them all to the front, you just get a whole bunch of A's at the front, right?
Yeah.
If there's any A's.
And then you can delete.
But you can
all
just
of them.
delete all the pairs of A's. So there's really just, there's never a repeated letter, okay?
Yeah.
Because anytime the letter repeats, you can just delete them.
Yeah. So basically, just don't include any repeats.
Yeah.
Yeah, so the question asks how many non-equivalent words are there, yeah? Is that what it asks?
Yeah. And a word can also be 1 letter, 2 letter, 3 letter, 4 letter.
Yeah.
0 letter.
So it could be the empty word, which it's just nothing, right? Or it could be one letter,
which
yeah.
says 9.
I kind of
Okay.
use it's basically just if you look, it's literally the ninth layer of Pascal's triangle.
Yeah, exactly.
Yeah,
So
and then you just add
so
everything
there's
up.
9. So you just learned this, right? There's 9 choose 0 ways of picking no letters, right?
Yeah.
There's 9 choose 1 way of picking 1 letter.
Yeah.
Yeah.
And then you just do it all.
9 choose 2 ways of picking 2 letters. Yeah.
Yeah, but then they start repeating, so you only need to really work out like to up to.
Oh yeah, because 9 choose 1 plus 9 choose
Yeah.
8 is the same thing.
Yeah.
Yeah.
So
Wait, but can you explain to me again why, like for the first one, swapping to adjacent letters, how do we avoid that?
how to avoid what?
Swapping to adjacent
They
letters.
have no repeated letters.
But like to adjacent letters.
Yeah, so have no permutation.
Oh, actually, there's also a typo in the question, isn't there? It says 2 adjacent letters when it should say like 2 identical letters or something.
I think it means like for example A B C can't become B A C. Because A B got switched to B A.
Where?
Huh?
Where?
The typo.
Yeah.
Yep. Yeah, consisting of just 2 adjacent letters. So it's the second last line.
Oh yeah, 2 adjacent.
6, 7, 8, 9.
Wait, so meaning there's no permutations, but couldn't there be more ways? Like let's say you have A B C, right? Instead of just switching 2 letters, you could go B C A.
Yeah, that's also a permutation.
Yeah, so we just permute them until they're in order. So then we don't care about the order anymore. So we always have A in front of B and in front of C. You know?
So you can just do like
Yeah.
So wait, what? So isn't one combination just A B C?
Yeah.
But then don't you have to times that by 3?
Because those are all equivalent.
Yeah,
Those are all
so
related.
You only find ABC.
Wait, how are they equivalent?
Because you just swap them.
Yeah, you just swap them. Yeah. I mean,
Wait, what? I don't get it.
It's so like ABC, right,
Yeah,
is related to BAC. They're related.
BAC, right? But ABC isn't related to BCA, is it?
it is.
Yeah, it is.
Because you can swap as many times as you want.
Yeah, you're allowed to apply the move a lot. So you can just shuffle A all the way to the front with 2 moves, yeah? Or maybe another way of thinking about it is
Oh,
that
you can switch it as many times as you want.
well, another way of thinking about it is BAC is related to BCA, right?
Yeah.
So like this is sort of related to that then.
Oh, I thought you can only use the remove once.
Yes.
Okay.
The remove thing. Sure.
Hmm?
This is by a sequence of the following operands.
Yeah.
So you can do it like as many.
Yeah. So I guess the good thing is for you is that the thing we just learned came back right when you need it.
Wait.
9, the choose notation. So then the question just becomes, so if the number of words with 1 letter, right? We're just picking like one of the 9 letters, yeah? The number of words with 2 letters, we're just picking 2 of the 9 letters, yeah?
How do you do 9 to 0? Is it just 0 and
This is-
0?
Oh, there's one way because
9.
you don't. There's no choices, right?
So
Yeah.
it's 0 on 0 equals to 1.
No, 9 choose 0 is just 0. I mean, it's just 1.
Why?
Because like
Oh, yeah.
there's one way to have 0.
There's only one way.
0, but like,
That's a reason.
I think
It doesn't follow the formula, is that what you're saying?
okay.
Oh no, well I mean the
Because you
formula.
can't
So
divide by
0
0.
factorial is defined to be 1.
Yeah. Oh.
Wait, why?
Wait, is it?
Because
To make something like this make.
So like they
Why
just
is
decided it should be.
I think
equal
I
to
heard why it is.
Okay.
wouldn't it just be 0?
I think the reason why I think I heard why it is.
I think that's because we have like
Yeah.
a
So
word with 0 letters, a word with 1 letter.
yeah. So how many words? So if the word has one letter, right? Yeah. Okay. So I'll explain this. Okay. So if the word has one letter, right? Yeah. Yeah.
Yeah.
The word could have 2 letters. It could have 9 letters. Yeah. But it can't have more than 9 letters because it'll have to start repeating letters. Yeah. And if it has 1 letter, how many? Okay, it could also have no letters. Yeah. Okay, if it has no letters, there's only one way to make that word, right? If there's 1 letter, there's 9 letters to choose from, yeah? There's 9 ways to make that word. If it's 2 letters, then there's 9 choose 2 ways to choose those 2 letters, yeah?
Yeah.
And we don't have to care about the order because the letters come in order, yeah?
Yeah.
Alright, does that make sense, Ethan?
Basically, it's like choosing already deletes all the time.
Yeah, I mean, the fact that we've already got them in order just means you just have to choose them. You don't have to order them, yeah?
Yeah.
So you are saying we can't repeat? Yeah, exactly. We can't repeat letters because if you have 2 letters which occur, you can just swap that letter until it gets to the next to the other letter that's the same, and then delete them both. Yeah. And can you see that's kind of awkward to explain, right? It's like if you have 2 letters, you can just keep swapping them, keep applying move 1 until it's like they already know what you're talking about. You're just kind
I
of
mean, like, how do you just say you can
Or
place
like
the
you just do
alphabet?
like a band explanation. Because just like a backup, you know?
okay. So maybe test Sylvia a little bit here. What's 9 choose 2 equal to? 9 choose 2.
I only just learned this as well.
Growing more and more confused.
9 times 8 equals 2.
So 9 choose 2. Okay, so this is the formula. You go 9 ways to choose the first thing, right? And then if you choose the first thing, there's only 8 things left, right?
Yeah.
Then there's 8 ways to
wait.
choose the next thing. And then you don't care about first and second, so you divide by the order. Yeah?
Oh.
Okay, what do you divide it by?
By
By the number of ways of ordering the 2 things.
So you can
yeah, it'd be 2 factorial.
Yeah, 2
So you could
factorial.
just do it like so it's the number of ways of ordering, so you mean like A, B, and then B, A?
Oh, that is right. 36.
Hmm?
36?
Yeah, yeah,
Okay.
yeah, 36.
Mhm.
Okay. And the good thing is, I guess, once you get to 9 choose 4, it starts repeating because choosing 4 things is the same as choosing 5 things.
And then
Because choosing 4 things is the same as leaving out 5 things, right? Or it's the same as choosing 5 things is the same as leaving out 4 things. So you're choosing the 4 to leave out instead of the 5 to remain, right? But it's the same. You get the same thing at the end. So 9 choose 4 is 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1. Okay.
It's kind of
So 5 is just this repeated again, right?
yeah, but like you can cancel out the 5.
18 times 7.
And then
is
6 is
basically
this,
the same.
and then 7 is this, 8 is this, and 9 is this, yeah? So we just need to double this, yeah?
Yeah.
And we'll need to get a double.
Okay, so this is,
Plus 9 plus 36 plus Plus wait, what's that?
So 1 plus 9 plus 36 plus,
Wait,
so
what's 12 times 7? 84.
Okay. It's like 20.
84.
Plus 2 times 3, 18. 18 times 7, 63, 63 times 126?
The people agree with that.
Okay.
Yeah, I think it's right. Yeah.
And then times it by 2?
And then what's that? So this is
0, 1, 2, 0, 2, 4, 6. 2, 5, 6.
Yeah, and then it comes
256.
512.
and 512. Yeah. Yeah. So actually, when you learn some algebra, so one of the things we kind of learn in the algebra class, I don't know if you've seen this, but it's pretty cool. Like if you take 1 plus x, yeah, and you take it to the power of 9, say, yeah,
Yeah.
then you get a bunch of things. Like you get there's like x cubed, x squared, all this other stuff, right? Um, but it's called the binomial theorem. It tells you what you get once you collect all the terms together. Okay. It tells you you actually get 1 plus 9x, yeah, plus 9 choose 2x squared plus 9 choose 3 x cubed. Not now.
What?
So you
It's basically plus 9.
have to wait till the
choose
end of
1,
this.
9 choose, and 9 choose 0.
Yeah, so 9 choose 9x to the 9. Yeah?
Because like 1 equals 9 choose 0. 9x equals 9 choose like 1.
Yeah.
And then, but why?
Wait, yeah. What,
Yes.
9 equals 9 choose 0.
Wait, but why?
I'm not explaining why right now.
Okay.
It's
Do you just have to expand it and then do 1 plus x?
no. It's actually a very nice reason. So it's kind of whatever power of x you get, you're really choosing which of the factors to pick the x to times the other stuff with. Okay. So
I kind of get you. I
yeah,
get your reasoning, but I don't. Like,
like I'm stating a fact. I'm not giving you a proof. You understand?
that? Suspicious.
Hello. Oh, okay. I'll set him down. No. You're not out of here, right? You finished this. If I let you go now, I would have let you go to the toilet, right? Just watch this as a one-line thing, okay? So this is true, okay? Right? And so this is
Is this true for all exponents?
for all x. And if you replace 9 with n, it'd be n, okay? Then you substitute x equals 1, yeah? Then you get 2 to the power of 9 equals 1 plus 9 plus 9, choose 2.
And then multiply everything to
Wait,
No, it's already there.
Oh, what? Plus 9 plus 9
But
choose
don't you have
2.
to do
4?
9 times x?
9 choose 2, 4, and then
X is 1.
Oh, yeah.
Sorry.
So when x is 1 to any power is 1, right?
Oh, yeah.
So you get exactly what we have, right? So this is the faster way of getting that is power of 2, okay? So the binomial theorem, it's in your extension 1 HSC syllabus, okay?
Of course it is.
But
2x plus x is
but
the
it's
same.
in our algebra 1 course for year 7s, okay?
2x plus x also.
So basic, yeah. So that's
Okay, so
basically the answer.
William, now you can go. So it's not good to leave in the middle of a sentence, you understand? Alright, so have a good week. See you. Okay, do you have any questions about this? Okay, I guess now the lesson's over, I can
Not
start.
really.
He said not really.
Not really what?